Hi, class. I have this question here. Let me get my pen. It comes from Unit 4's homework. Looks like it's Unit 4, Homework 1, problem number 4. Let me check and confirm that right quick. Yes. Okay, so let's go ahead and take a look at it right quick. Okay, so the question here, I'm not going to do this exact question, but here's what it's like. It says, construct the confidence interval. The level of confidence is 0.90, which, by the way, remember, is 90%. So basically this says construct a 90% confidence interval with a sample mean of 8.8 with a population standard deviation of 0.4 and then a sample size of 41. Okay, we're not going to do this exact one, but what I'm going to do is I will do a 90% confidence interval, but I'm just going to change up these values here so it's not exactly the exact same thing, but the process is still going to be the same. So let me type sort of just a new one here just to give you a frame of reference of what we're doing. So what is the 90% confidence interval for a sample mean? And remember, sample is the X bar or X of 5.2, population standard deviation of 0.25, and sample size of, we can make anything up, let's do 49. Okay, so you want to be, one thing to be familiar with is the symbols. X bar, the X with the bar over the top of it, that's the sample mean, and the sigma here means you're dealing with the population standard deviation. And if you haven't reviewed the Unit 4 Zoom session, the videos that I posted for Unit 4, I encourage you to do so. Which, by the way, let me take you there. Go to announcements, and then I posted a video here, review of confidence intervals. I give you the step-by-step process of how to do confidence intervals. So please do take a look at that because I think you're going to find it very helpful. Okay. So with that in mind, let's go ahead and take a look at this. What do we do? Well, the process basically is you first have to, let's set our information. What do we have? We have the sample mean in this problem here. We're focusing on this problem. Sample mean X bar is 5.2. And our sigma, our population standard deviation, is 0.25. And then our sample size is 49. Okay. The process for finding this, the confidence interval is basically you have to find the margin of error, because once in the margin of error is denoted by the letter or the capital letter E. That's the margin of error. That's what we have to find. Now, because once you find the margin of error, you take your X bar and you subtract it from, the margin of error from it, whatever that's going to be. And then you take your sample mean X bar and you add the margin of error to it, whatever that's going to be. So the key to the whole thing, we know what our X bar is. There it is, 5.2. We're just trying to find what's the number that we're going to add and subtract 5.2 from. The formula for finding E, the margin of error, is Z critical times the population standard deviation divided by square root of the sample size. Now, we know the population standard deviation, it's right over there. We know the sample size, it's right there. So let's plug those in. The only thing we don't know, and really where the work comes down to, is what is our Z critical value? How do we find it? Well, that's where the 90% comes into play. That's the work. That's the work. And basically what we're going to do, and there's a reason why we're using the letter Z right here, because the Z tells you what table you have to use. The Z normal distribution table that we used back in Unit 3. So how do we do this? Well, 90% is the same thing, convert it to a decimal, as 0.9. That is what we call our C value. Notice that's why we put it right here, our level of confidence. What you do is you say 1/2 times 1 minus C. Okay, you're trying to find let's step back. The confidence interval, we're associating this with the normal distribution. And a confidence interval is always two-sided, an upper bound and a lower bound. Now, this level of confidence is subtracted from 100 or 1, so leaving 10%. Half of that 10% is going to go over here, and half of that 10% is going to go over here. So essentially what we're trying to find is we're trying to find the Z critical values associated with that so that we have 90% in the middle. That's what we're trying to find. And so that's why we cut it in half, because there are two tails, one on the left side, one on the right side. So here we take the 0.1. Where did the 0.1 come from? 1 minus C, in this case, 1 minus 0.9. This 0.9 is equal to 0.1. And remember, we cut it in half. Cut it in half. So what do you get when you cut 0.1 in half? 0.05. So half of that error is going to the left and right tails. Now you only need to focus on one of them. So let's focus on this. Okay, doesn't matter, you can pick either one. What you do once you have the 0.05, then you go to your normal distribution table. Let's do that. Let's go to our normal distribution table. And what we do is we look for 0.5 corresponds to, remember 0.5 is an area under the curve. I'm sorry, 0.05. 0.05 is an area under the curve. It's also associated with a probability. We find 0.05 in there. So scroll down to find 0.05. Oh, wait, well, 0.05 is not here because look, these are very high values. So we got to go to the first page. Scroll up. Sorry, I clicked the wrong button here. Okay, so let's find 0.05. So here's 0.055 and here's 0.0495. So 0.05 is going to be right here in between the two. So what's the Z-score associated with that? Go over to the left, negative 1.6, and go up to the top row. And this is 0. Halfway between 0.04 and 0.05 is 0.045. So come over here and get those two, bring those two values over. 1.6 from the left-hand column right here, and then 0.045. Now we don't add them, you just combine them. Bring down the -1, bring down the decimal, bring down the 6, bring down the 4, bring down the 5. That is the Z-score value associated with the probability value of 0.05. So what we're trying to do then is we found this value over here. Remember, the area is 0.05. The Z-score value corresponding to that right here is the -1.645. What you want to do, because it's symmetric, because the normal distribution is symmetric, then you just turn it positive. to get this side. And so that's our Z, this is our critical value. These are our critical values, negative 1.645 and positive 1.645. Those are the lines at which we go from being inside the confidence interval to being outside of the confidence interval, because remember, we're trying to be inside here. Okay, so these are the boundaries, if you will. Those are the z-scores associated with the boundaries. So that's why we call them critical values, because they give us the measure of the boundary. So let's take our value of 1.645 now and go back to our first page. Okay, so I missed, I erased the problem. Okay, so that was the whole thing. I think I sort of remember it. I had X bar of 5.2. Yeah, I'll just make something up. X bar of 5.2, sigma 0.25, and then sample size of 49. Okay, and remember what we were trying to do is we were trying to find the margin of error. The formula is Z critical times sigma over the square root of the sample size, n. The Z critical is found by the C value. Take 1 minus C. Remember, we do 1 minus C over 2, or 1/2 times that. And that's how we got 0.05. Go to the normal distribution table. Go to the Z table. Find the Z-score value associated with that probability. And we found that to be 1.645. Take the positive value. That's what that value is right there, 1.645. Oops. Plug in your standard deviation. Plug in this and simplify. And so this is where you have to break out your calculator now. We could do some simplification, but let's break out our calculator. When I do this calculation, I do 1.645 times 0.25, and then divided by the square root of 49. And so I get a margin of error value of E equals 0.0. Now I'm going to round it to 2 decimal places like the problem asks, 0.06. And so now that we have the E, remember at this point, you take your sample mean and subtract off the E, take your sample mean and add the E. So what do we get? Well, let's do some typing now, maybe a little easier for us. So we get X bar is 5.2 minus 0.6. So that means we get 4.14. Oh, yeah, 4.14, that's right. And then here, we get 5.2 plus 0.6, and that gives us a value of 5.26. And that's it. So these are the values, the values of 4.14 and 5.26. These would be the values that you put in there. The whole thing is you have to know or recall the margin of error formula. The Z critical value is associated with the confidence, level of confidence. To find the Z critical value, you do 1 minus C over 2 and go to the Z score table to find the Z score value that is associated with that probability. Come back, plug it in, and then plug in your standard deviation and your sample size. Find your value of E, and then take your value of E and add and subtract it from the sample mean to get your upper and lower bound of your confidence interval. And that's it.